Hey calculus, today we are going to learn our second derivative rule. We know the power rule. Today we're going to learn the chain rule. But first we're going to learn a couple of trig derivatives. So the first one we're going to learn is the derivative of the sine. So up here in the red curve is the graph of the sine. Remember, it starts in the middle, goes to the max, the middle, the min, the middle. So this is the sine. It starts in the middle and goes up. If we take the derivative of that, if you look here, the sine is increasing right here. All right, so we know that the derivative has to be above the x-axis all the way to that maximum. And if you look, this graph right here is above the x-axis until that point. We know that there's a maximum here, so we know that there has to be an x-intercept on the derivative at that same x value, and there is an x-intercept right here. Alrighty? Now our sine graph starts decreasing right here. So it is decreasing all the way until that minimum. So we know when a function is decreasing over an interval, the derivative has to be below the x-axis. And this is below the x-axis right here. So that holds true. Now right here we have a minimum. So we know there has to be an x-intercept right here. The minimum is right here, right about here, and the x-intercept is right there at that same x value. So that is working out. Oops, excuse me. All right, and then finally, the graph starts increasing again. And when a graph is increasing, its derivative is above the x-axis right here. So this graph up here in the blue, that is the cosine. All right, this is the cosine graph. Remember, it starts in the max and goes down. So right here, the derivative of the sine is indeed the cosine of x. So that one you just have to know. The derivative of the sine is the cosine. All right, the derivative of the cosine, if you just take this sine graph and flip it, you would have the derivative of the cosine. So I'm just going to give this one to you. The derivative of the cosine is negative sine of x. So these are going to be the start of our derivative function flashcards. The derivative of the sine is the cosine, and the derivative of the cosine is negative sine of x. All right, now we're going to learn the chain rule. The chain rule is a derivative rule used to take the derivative of composite functions. Now, what is a composite function? A composite function is a function that is composed of, it's made up of two or more separate functions. So one function is built into another function. All right? One way that we can recognize a composite function is that you see more than one function, but you only see the letter x one time. Let's go look at these two examples down at the bottom of the page. Right here. All right, now, the sine squared of x, this one right here, that is written in that weird trig notation. But if you rewrite this, anytime in the trig world where you have an exponent between the trig function and the variable, that exponent applies to everything. So another way to look at that is this. That's the same as the sine of x all squared. All right? These are the same. This is just written in that trig notation. So my advice would be to, when you see that weird trig notation, rewrite it, because then you can truly see what's happening. You have two functions here. You've got something squared and you have the sine of x. So you have one function built into another. You only see the letter x once. That's what a composite function is. You have one or more functions built into another. All right, over here, the next example, again, you have two functions here. You've got the sine and you have x squared, the sine of x squared. I only see the letter of x once. All right, so that's what a composite function is. All right, we use the chain rule to take the derivative of composite functions. So here are the steps. The first thing we're going to do is we're going to label our inside and outside function. Now, how do you figure out what's outer and what's inner? The outer function is what is doing something to the other function. Okay, so let's go right here. Which function, the sine of x or squared, is doing something to the other function. We are squaring the sine of x. All right, so the function that is doing something to the other function is always the outer function. So in this example, the outer function, and we write it like this, is something squared. And the inner function is the sine of x. Now you can also kind of see by looking at it, this squared is on the outermost part of the function. All right, but the outer function again is what's doing something to the other function. All right, if we wanted to look at example number 2 and figure out what's outer and inner here, you read this here as we are taking the sine of x squared. We are sining x squared. So in this example, the outer function is sine and the inner function is x squared. We are doing this to this. All right, the more you do this, the better you will get at recognizing what's outer and what's inner. It is hard, but again, this is something that you will get better at the more you do it. All right, so let's go back up to our chain rule. There are 3 steps. All right, the first step is you take the derivative of the outside function. You always put in a blank set of parentheses at this step. There is no x here. You take the derivative of the outer. So let's go down to example number 1. All right, if we want to take the derivative of this outside function, we use the power rule. All right, remember, the derivative of x squared is 2x to the first. So we do the same thing here. The derivative of something squared is 2 times something to the first. So when you take the derivative of the outer, there will always be a blank set of parentheses. You never put in an x. So label that. That whole gig is the first step of the chain rule, the derivative of the outer function. Okay? The second step is you plug in the inside function as is, inside that blank set of parentheses. So our inner function is the sine of x. So I plug that in inside the set of parentheses, the sine of x. So if you want to label it, that is the inner function as is. So that's the first 2 steps of the chain rule. You take the derivative of the outer function. The second step, you plug in the inner as is. And now the third step, it is always multiplying. You multiply that whole thing by the derivative of the inside function. So we just learned, what is the derivative of the sine of x? Well, we know the derivative of the sine of x is the cosine of x. So we multiply everything by the cosine of x. That is our derivative of the inner function, if you want to label all 3 parts. So there you have it. The derivative of the outer, 2 times something to the first. The inner as is, plugged in, the sine of x, and the derivative of the inner. Now when we simplify that, we just write it as simply as we can. 2 sine of x times the cosine of x. And there you have it. Okay, let's go to number 2. We already talked about it. We're taking the sine of x squared, so the sine is the outer, and the x squared is the inner. So the first step, we take the derivative of the outside function. The derivative of the sine is the cosine. And you always put in a blank set of parentheses. All right, so this whole thing here is the derivative of the outer. The second step of the chain rule, we plug in the inner function as is, right inside that blank set of parentheses. So that is my second step. So that is my inner as is. And the final step, we multiply everything by the derivative of the inner. To take the derivative of x squared, we use the chain rule, and that is 2x. So this right here is the derivative of the inner. So we have all 3 steps. Now to simplify it, in the math world, you always want to put any coefficients out front. They always go in the front. So when we rewrite this, I'm just going to put 2x in the front times the cosine of x squared. So you always want to simplify it, and that's as far as you need to go. Number 3, again, always rewrite when you have that weird trig notation. This 4 right here applies to everything immediately to the left and to the right of it. So when we rewrite this, it looks like this. 3 times the cosine of x all to the 4th. If you rewrite it this way, it is much easier to see what's outside and what's inside. Here, something to the 4th is the outside function, because we are fourthing, if that's a word, the cosine of x, outer and inner. Now, this coefficient, in the derivative world, the coefficient always comes along for the ride. So make it part of your outside function. Then you won't forget about it. So the 3 comes along for the ride, and the outside function is something to the fourth. The inside function, and it even looks like it's on the inside, is the cosine of x. All right? So the outer function is something to the fourth, the inner function is cosine of x. So the first step in our chain rule is we take the derivative of the outer. So we're just going to use the power rule here. 4 times 3 gives me 12 times something, and when we take 1 away from this, 4 minus 1 gives me 3. So my outside function is 12 times something to the third. That is the derivative of the outer. The second step of the chain rule, remember we plug that inner function in as is in that blank set of parentheses. So 12 times something to the third, and then we plug in the cosine of x. That is my inner as is. All right. Third step, we multiply everything by the derivative of the inside function. And we know that the derivative of the cosine is negative sine of x. Now, make sure you put that in parentheses so it doesn't look like subtraction here. It's times negative sine of x. So if you want to label that, that is the derivative of the inner function. Okay, to simplify it, this -1 coefficient gets multiplied by this coefficient, and we put -12 out front. All right, so we have -12, we have the cosine of x to the third, and then we have times the sine of x. All right, the order of these two things doesn't matter. You could write -12 sine of x times the cosine of x to the third, but that -12 has to go out front. Number 4. 4 sine of 10x. We're taking the sine of 10x. We are sining 10x. So that is my outer function. So bring the coefficient along, put it as part of your outer function so you don't forget about it. And the inner function is 10x. And now we go to work. The 4 comes along for the ride. The derivative of the sine, the derivative of the outer, is cosine, and we always put in a blank set of parentheses. That whole thing there, that is the derivative of the outer, first step of the chain rule. The inner as is, we plug in right there, 10x. That is my inner as is, and we multiply everything by the derivative of the outer using the power rule. The derivative of 10x is times 10. So that is my derivative of the inner. Now, to simplify, you multiply the 4 and the 10, and you put 40 out front. So we have 40 times the cosine of 10x. And that's as far as you need to go. Number 5, this is a composite function because we have a negative x here. If it just said cosine of x, that's one trig function. But because it's negative x, that is 2 separate functions. So we are taking the cosine of negative x. So we are cosining negative x. So our outer function is cosine. My inner function is negative x. All right, first step. We take the derivative of the outer. The derivative of the cosine is negative sine. And always put in a blank set of parentheses. That is the derivative of the outer. Second step, we plug in the inner as is right in there. So my inner as is negative x. So that's where that goes. Second step, the inner function as is. And finally, the third step, we multiply everything by the derivative of the inner. Well, the derivative of negative x is just times -1. And I would put that in parentheses again so it doesn't look like subtraction. Now to simplify this, the only thing that we have to do is multiply this -1 times this -1, and we get a +1 out front. So that is sine of negative x, and that is as far as we can go. The derivative is the sine of negative x. Number 6, 7 times the sine of 2x plus 5. Our two functions are sine and 2x plus 5. We are sining 2x plus 5, so this is my outer, and this is my inner. So my outer is 7. Bring the 7 along so you don't forget about it. 7 sine, and my inner is 2x plus 5. Okay, we go to work. For the derivative of the outer, the 7 comes along for the ride. The derivative of the sine is the cosine. And you always put in a blank set of parentheses. So that whole thing right there is the derivative of the outside function. Second step, we plug in the inner as is right inside that blank set of parentheses. So 2x plus 5. That is my inner as is. All right, third step, we multiply everything by the derivative of the inner. To take the derivative of this is a power rule. The derivative of 2x is 2, and the derivative of 5 is 0. So the derivative of our inner is just 2. That is the derivative of the inner. Okay, to simplify this, you always multiply the coefficients, the numbers. We have a 7 and a 2. 7 times 2 gives me a 14 out front. So we have 14 times the cosine of 2x plus 5. And that is your final best answer derivative. Number 7, we have two functions here. We have a cubic function. This is just one cubic function, x cubed plus 7, and we have something squared. So two functions, one chain. The outer function is the squared because we are squaring x cubed plus 7. So our outer function is something squared, and we write it just like that. My inner function is x cubed plus 7. Okay, the derivative of the outer, this is going to be a power rule. The derivative of something squared is simply 2 times something to the first. That whole gig is the derivative of the outer function. It's just a power rule. You need a blank set of parentheses, so that's how we write it. Now, we plug in the inner as is, x cubed plus 7, right inside there. So there's my inner as is, x cubed plus 7. So that is my inner as is. All right, and finally, the last step of the chain rule, we multiply everything by the derivative of the inner, and these are power rules. The derivative of x cubed is 3x squared. The derivative of 7 is just 0. So this right here, of course, is the derivative of the inner. Now to simplify it, I'm going to multiply the 2 and the 3. And I am going to put the 6x squared out front times x cubed plus 7. There's the derivative. Finally, number 8. We have two functions here. This is one quadratic function, x squared plus 3x minus 4. Our second function is something to the 100th. We are 100thing this whole quadratic function. So our outside function is something to the 100th. And our inside function is the quadratic, x squared plus 3x minus 4. All right, first step of the chain rule, the derivative of the outer. Well, the derivative of something to the 100th, power ruling that would be 100 times something to the 99th. Lots of fun. So that whole gig is the derivative of the outer. Second step, we plug in the inner as is right here. So we plug in x squared plus 3x minus 4 inside of that parentheses. So that's the second step, the inner function as is. All right, now the last step, we multiply everything by the derivative of this. So this is all power rules. The derivative of x squared is 2x. The derivative of 3x is plus 3, and the derivative of negative 4 is 0. So this whole thing here is the derivative of the inner function. All right, to simplify, you're never going to take anything to the 99th. So we're going to leave that alone. X squared plus 3x minus 4 to the 99th. That comes down. Okay, now right here, this 2x to the plus 3 is to the first right there. All right, so I can distribute the 100 to this. All right, so I'm just going to go off to the side. 100 times 2x plus 3 to the first, we can distribute that. So we get 200x and then plus 300. So that is my derivative right there. 2x plus 200x plus 300 times x squared plus 3x minus 4 to the 99th. There you have it. There is the introduction to the chain rule. Now you're going to go practice it on the homework worksheet. Bye, calculus.